Today we're going to be looking at some problems that emerge in early modern philosophy. That is the title usually given to the philosophy of the 17th and 18th centuries. And we're going to be looking at a fundamental distinction, a basic metaphysical distinction that philosophers in that era draw. It's something that comes out of the discussion of essences, essential properties versus accidental properties, in Aristotle and the later tradition, up to and including Aquinas. But it's something that gives it a unique twist, a very special twist, because of basically the scientific revolution. In the 16th century, and then especially in the 17th century, there were major advances in science. Figures like Copernicus, Galileo, Newton. And those people developed a theory of nature that was mathematically precise, that allowed for the development of technology, that overthrew the traditional Aristotelian framework in the sciences, and also, less directly, ended up overthrowing the Aristotelian perspective in philosophy. Why? Well, because it implied that this theory of substance, this theory of objects, had to be complicated in ways that Aristotle himself never envisioned. According to the scientific revolution, there are all sorts of things going on in nature that are not evident to our senses. And so in particular, we have within any substance atoms structured into molecules and responsible, according to these theories, for the behavior of the macroscopic articles, or objects. Now, it wasn't until the early part of the 20th century that people really had a very solid theory of the atom. Nevertheless, by the time John Locke is writing, for example, in the 17th century, Locke is already talking about atoms and molecules, as at one point he's talking actually about photons and the way in which our eyes receive information from the world. And he says, well, light comes into the eye in something like the way that a tennis ball might bounce off an object and bounce into the eye. And so he's imagining a photon or some other things, even when people didn't have names for them, they already have the conceptual tools. They realize that the behavior of macroscopic objects is often given to us and determined by the motions of the microscopic particles that make them up. And Newton, of course, gives us laws that start out being laws governing the motion of the planets, but are also taken to explain the motions of projectiles, the motions of objects on Earth. So according to the atomic theory, things are composed of atoms, and the properties of things depend on the nature and motions of those atoms. Well, it's a simple and familiar idea to us. It goes all the way back to ancient Greece with Democritus. But here is its philosophical take. It implies that things are not as they appear. So, I look here at the blackboard, for example, and I seem to be seeing one continuous substance. And yet, according to the atomic theory, it's actually a very complex thing. It consists of tiny particles, and actually lots of empty space. It appears to be stationary, but according to the atomic theory, those particles are actually in motion at a very rapid rate. And so the actual nature of the blackboard is quite different from the nature that it seems to have, just on the basis of my eyes, or on the basis of hearing, or on the basis of touch. All of those things give us some idea of the object. But according to the atomic theory, there is a hidden nature of that object that is actually the crucial thing to understand. Well, if that's right, then we get a complication in the underlying theory of substances. Aristotle sees objects as causing perceptions of them, and as also represented in those perceptions. It's an entirely common sense view. I see the blackboard, the object, the blackboard is in some way the cause of my perception of it, and my perception represents the blackboard. Well, at a certain level, all of that seems, if not trivial, at any rate, pretty obvious. That's something that seems utterly natural to us. But it implies something important. The cause of perception is the same thing as the object of perception. It's the same thing as the thing represented in the perception itself. But the atomic theory says, look, that's not really right. What is the cause of my perception? Yes, it's the blackboard, but it's actually the microscopic parts of the blackboard that are interacting with light in a certain way to produce this sort of result inside me. And so my perception is something that arises from causes that ultimately have to be understood in terms of the atomic theory. Well, that's not what I see. I don't see the atoms. I look here and I see what seems to be a solid surface that is quite uniform. But actually, that's not what it's like according to the atomic theory. So the object as represented in my perception is, according to the atomic theory, quite different from the ultimate causes of that perception. That can lead you to think the objects that we ordinarily talk about, and this includes not just blackboards, but all the objects around us, tables, chairs, automobiles, and most crucially, other people, they are not really as they appear. What is actually causing them to behave the way they do is something hidden from us, something at the level of the atoms. So the objects emerge as mere appearances. Well, if that's the way we start thinking about things, we think the causes of our perceptions are really the atoms, but those are things we don't see. We see their effects. We see what they do, and in particular, how they affect our own perceptual and cognitive faculties. We know how they affect our sense organs, but we don't see them. And so it implies that what we see, or at least what we see as it is seen, is not what's really there in reality. So it can lend this idea that, gosh, the world as we perceive it is really very different from the world as it truly is. We are seeing something that is a construction of our own minds, our own perceptual faculties, and that may or may not match up with the true nature of the world. So I look here and I see a room filled with chairs and people. Do those chairs and people really exist? What's really here in the room? And most crucially, I guess we could say, let me look at you, and in particular think what properties of you are really in you, and which of them are being supplied by my own perceptual faculties. That's not an easy question to answer. And so the question arises for these 17th and 18th century philosophers, if the true causes of our perception are not the things as they are represented, but something else revealed in the end by physics, then what we see doesn't exist in the same form in reality. Something might, that is to say, perhaps in some respects, my perceptions of things agree with the nature of the things in themselves, but certain aspects of those perceptions are undoubtedly being supplied by my own sense organs, by my own brain. And so, how do I distinguish the aspects of these effects, these things as represented in my mind, that are really in the world, from those that are merely appearances constructed by my own mind? So, let's take a very simple story. I look over there and I see whatever this is. Okay, I guess it's some kind of alert system. It flashes as the building catches on fire, so it's some sort of fire alarm. Now, I look at the fire alarm, and it appears to me to be a certain way, and yet according to physics, what's actually going on here? There are microparticles there. There were complex fields, electromagnetic fields, among other things. And that is affecting my perceptual organs in a certain way. Light is coming from there into my eye and into your eye. It produces a certain image on the retina. Most of that information that's there on the retina gets thrown away by the optic nerve because it can only take so much. We don't want an optic nerve the size of a transatlantic cable. And so actually a tiny portion of that is transmitted to the brain. The brain then takes these electrical impulses and turns those into a three-dimensional representation of what is actually just a two-dimensional representation on the retina. Now, there's a lot of processing that goes on here. First of all, the effects on the retina, on the cones and rods, which end up being transmitted, at least partially, through the optic nerve. Then we've got impulses in the brain. That produces a certain representation within your mind. Well, what features of that representation are accurate, or getting it right, are the way that reality really is, and which are being supplied either by the eye or by the brain in that entire process. How do we tell? The philosophers of this era answer the question in the following way. They say we've got to draw a distinction between primary qualities and secondary qualities. The primary qualities of an object are the properties the thing actually has. Okay, the things that correspond to the way the thing is in the world. So their answer is basically, you're absolutely right. There are two kinds of properties, some of which are represented as they are in reality in our cognitive systems, and others of which are not represented as they are, but actually, well, I shouldn't say that. They're properties of the thing as represented, that really correspond to the reality. There are things about my representations that are being contributed by my own cognitive faculties. So the primary qualities are the things that really exist in the object. They are mathematical properties assigned to atoms by physical theory. At least this is the way Descartes understands them. Descartes says, yes, and actually he's taking this distinction from Pierre Gassendi. He is saying there are things that really are out there in the world and that really do have these properties. What are these properties that are really representing the way things are? Mathematical properties. Size, shape, mass, motion. The things you would write down about the object in physics, those are really there. And how can you tell which properties these are? Well, physics tells you. It's the job of the physicist to say, what are the properties that are actually in the world and can be described in the language of physics? The secondary qualities are the effects of those primary qualities on us. They are the aspects of the thing as represented by us that are actually part of the representation but not in the thing. They are the effects on us, the things that our cognitive faculties are contributing to that representation. So what are those things? Well, they're the things that are not described in the language of physics. So things like color, texture, moral and aesthetic qualities. I show you this table, and I say, describe the table for me. Well, what are some things you might say if I say, describe the table?
4 legs.
Okay, it has 4 legs. Primary quality or secondary quality? Primary. Okay, good. What are some other things you might say about it? It's brown. Good. Is that primary or secondary?
Secondary.
Secondary. Excellent. It's made of wood. Primary or secondary?
Primary.
Primary. Good. What else? It's stable. Yeah. Is that primary or secondary? Yeah. There's a little bit of disagreement about that. It becomes a question, well, can we explain what stability would mean in the language of physics? Let's say we can, because it means basically that it is not displaced by a certain level of force. And so maybe that's something we could actually define in physical terms. There are going to be things like that aren't found literally in the language of physics, but nevertheless could be defined in physical terms. Some other things you might say about the table. Yeah?
Rectangular.
It's rectangular. Primary or secondary? Primary. Good. Anything else? Is it a good table or a bad table? Yeah. Is it beautiful or ugly? Yeah. All right, no disagreement about those things. Let me think about something that's really bad. Do we have an example? Well, this isn't bad. Look at all of these water bottles that people leave behind in this classroom. Look at this particular one. Good water bottle or bad water bottle? Okay, he said bad. Primary quality or secondary quality? Secondary. Good, okay. So you get the idea. Some of these things are held to be really in the thing because science describes them as having those properties, or at least those kinds of properties. Other things are not in the things themselves. They're not really something we can easily define in the language of physics. Those have to do with the effects of things on us. So Descartes says, yeah, we perceive distinctly in theory only the mathematical properties of things, only size, shape, and motion. Only they reflect the true nature of things. And that idea is something we're going to come back to, by the way. His idea of perceiving certain things clearly and distinctly is one of Descartes' fundamental notions. But for now, don't worry about it. We'll have plenty to say about it later. So this is size, shape, motion, things that could be defined in terms of that. Those are the primary qualities of things. Locke defines it slightly differently. He says that a primary quality is inseparable from the object. Even the atoms have these properties. So anything you could say about the atoms, and here I think what he has in mind is anything you could say in the language of physics. For example, he doesn't mean to say, oh, a primary quality would be like being super tiny. I mean, that would be an example of one, but he's not saying that anything. For example, there are no atoms that are 6 feet tall, but if a person is 6 feet tall, that's still a primary quality of the person. It's the kind of thing we can attribute to the atoms themselves. Primary qualities are those qualities that things possess according to the atomic theory. However, here's the story you have to tell them. They produce certain ideas in us, and he says those ideas are simple ideas. They resemble the primary qualities of the atoms. So things have a certain length, I perceive them as having a certain length, and my perception resembles, in some respect at any rate, the actual quality of the object. Well, what about secondary qualities? They are effects of objects on our nervous system. So color is the paradigm example. They produce ideas in us that don't resemble them. The blackboard is, well, not exactly black, it's really sort of a charcoal gray. Are the atoms in it charcoal gray? Was it made with charcoal gray electrons? In something like the way my father used to tell me that chocolate milk came from brown cows. Well, no, right? The atoms themselves don't have any color, the electrons don't have any particular color. That's not what's going on here. It has to do with the arrangement and the effect that has on our own cognitive faculties. And so secondary qualities are those effects. They're aspects of our representations, our perceptions, for example, that are not actually in the things themselves. And those produce ideas in us that don't resemble them. For example, certain patterns of wavelengths of light presumably have the effect on us of letting us see color, but that doesn't mean that colors are themselves primary, though some people argue that, by the way. But in his view, and in Descartes' view, the colors are effects of those kinds of complex physical properties on us. Things have primary qualities involving shape, size, motion, arrangement, things like that, and then those things have effects on our cognitive faculties, but effects that are not at all like those things themselves. Well, the secondary qualities do depend on the primary qualities. It's not as if the color I see a thing as having is just utterly unrelated to the way the thing is itself. It is transmitting light at certain wavelengths, or reflecting light at certain wavelengths, and so that's something that is relevant to the way I perceive the color. On the other hand, the way in which it's relevant is actually much more complicated, cognitive psychologists are figuring out, than people initially thought. You can't just define red as light between these two wavelengths or something. Our perceptual faculties are more complex than that. So you might say, look, in the end, these secondary qualities do depend on the arrangement, on the wavelengths of light, and things like that. But on the other hand, a secondary quality is really what a lot of philosophers have defined as response-dependent. Meaning to have such a quality is really just to produce a certain kind of response in a normal perceiver in normal situations. So, what is it to be read? It's really just to be perceived a certain way by normal perceivers in normal circumstances. It's really important to put those qualifications in, because some people are colorblind, okay? And some animals don't see color at all. And so it's not as if every perceiver perceives colors in the same way. Moreover, you can trick people about the colors of things. I put strange lighting there, and it might be hard to tell what color something truly is. A lot of amusement parks have a fun house where you go in and there's strangely colored lights, and you look down and it looks like you've got neon clothing on or whatever. And those are meant to make you misperceive what colors things are. So it's important that we say this is the effect it produces in perceivers under normal circumstances, given that they're normal perceivers. So to be read, for example, is just to look red to a standard perceiver in standard conditions. Now that has a link to it, and it depends on certain primary qualities, certain arrangements of parts, the reflection of certain wavelengths of light. But on the other hand, really in the end, to be read is just to look like that. Now, remember we were talking about essential properties earlier, and in Aristotle we find different representations of what an essential property is. The essence of an object X could be what it is to be X. What X is by virtue of itself. Properties say what X is by its very nature, and then what's expressed by a definition of X. As Aristotle puts in a formula, the nature of X. Those are things that he takes to be equivalent. He's trying to tell you the same thing in each case, but they don't look equivalent necessarily. Those are things we might draw distinctions among. And indeed, we've seen that Aquinas does draw some distinctions here. Aquinas says, well, be careful. There are at least two things that we're dealing with under this general heading of essence, things that are properties necessary to the object, without which it wouldn't be what it is. There is what he calls the quiddity. That's what corresponds to the definition in the world. And then there's the nature, what makes the thing what it is. And so Aquinas is still, before the atomic theory, and before the scientific revolution, saying, well, Aristotle really has two very different concepts here. Maybe three if we take the properties necessary to the thing as a third one. But at least he thinks they all agree in the end. So he says there are three different concepts, but nevertheless, the same properties satisfy all of those concepts. After the scientific revolution, people look at this and say, wait a minute. Actually, they're not satisfied by the same things. So we've already seen an example. The essence of wax is the properties necessary to wax, without which it would be wax. Well, its quiddity is something that corresponds to its definition in the world as we would ordinarily understand it. It's related to our concept of the thing. But the nature of wax is what makes wax what it is. And now, after the scientific revolution, you tend to hear that as, oh, this has to do with the micro properties that make it be what it is. So it's easy to look at this quiddity idea. This corresponds to the definition and think, yes, we can look that up in the dictionary. But the nature of the thing, that's something to be explained ultimately by science. So after the scientific revolution, in the presence of the atomic theory, people look at these and say, actually, they don't pick out the same properties at all. These are quite different ideas. And so we talked about this. Here's one way of looking at what's the essence of wax. Here's one at the level of common sense, at the level of secondary qualities. It's a compound that's malleable near ambient temperatures. But the nature of wax, that's an organic compound that consists of long alkyl chains. Things like C3H5 or C3H7, like that kind of thing. And so that's a very different way of understanding it. That is really what explains why it has the properties it has. That's what makes wax wax. On the other hand, the way we define wax is usually not that. Okay? Now, there are lots of simpler examples. And so Locke gives us some, I've already said that. Locke gives us some special terms here. Terms that end up being very influential. The nominal essence of a thing is what Aquinas would have called its quiddity. It's what corresponds to this sort of common-sensey definition of the thing. It uses secondary qualities. It's something like wax is this malleable stuff. Whereas the real essence of the thing is its internal nature, its scientific nature. The real internal constitution is the way that Locke puts it. So, we can ask about something like oxygen. What is oxygen? Give me a definition of oxygen, just in common-sensey terms, without science. Actually, it's sort of hard, right? Because it's not something we have a real clear concept of apart from science. But go ahead, try it. What we breathe. Okay, good. What we breathe, it keeps us alive. Now, I ask you for a scientific definition of oxygen. What is it that makes oxygen oxygen? Tell me about its real internal constitution. What would you say? I'm sorry, I didn't get it.
An element with a certain amount of protons? I don't remember what.
Yeah, good. Okay. Yeah, it's an element that has a certain position on the atomic chart. If I remember correctly, it's atomic number 8. And that's something that would characterize what it is, what makes oxygen oxygen. So, let's think of some other examples. Gold. What is gold? Well, if we can talk about its essence, but it comes apart into these two ideas. There's a real and a nominal essence. The nominal essence, Locke says, is just heavy yellow metal. I don't know if that's probably wrong, but nevertheless, that's what he says. But the real essence, well, that's something he was in no position to identify, but he said, look, it's whatever is the internal constitution that makes gold gold, that makes it have the properties that it has. And now we would say it's the thing, it's the element with atomic number 79. So those are two very different ways of defining what gold is, of characterizing its essence. And the same thing, well, there we go. Atomic number 79, atomic weight 196.966, blah, blah, blah. Okay. What about water? How would you define water in common sense terms? Well, lakes are full of it, yes. Well, okay, good. Is this liquid essential to life? What is it in scientific terms? H2O, good. So its nominal essence is something like a colorless, tasteless liquid that at common temperatures necessary to life. But its real essence is H2O. And so those are very different things. Now notice one is a description of water at our common sense level. It uses secondary qualities. The other is characterized strictly in terms of primary qualities, and it really, in the end, becomes a scientific definition of a thing. Now, there's some interesting examples that philosophers have talked about later. For example, elms and beeches. Those are very similar trees. They look pretty similar, and if you look up those things in the dictionary, they just say they're common North American deciduous trees. And so it looks as if they actually have the same nominal essence. But on the other hand, they don't have the same scientific nature. What makes an elm is quite different from what makes a beech a beech. One is Ulmus americana, and the other is Fagus grandifolium. And so biologically, they're quite different. They are not at all the same, even if they sort of look the same. Okay, so now here is how we can fit this into our little picture. This is a picture that talks about denotation and denoting an object, but also something meaning or connoting an essence. And according to the theory that had been developed by people like Aristotle and Peter of Spain and Aquinas, in order to understand how a word like triangle is functioning, and how in general words in language function, we have to understand the difference between a meaning or a connotation and a reference or a denotation. Well, the thing connoted, the thing meant, is supposed to be an essence. But now, if we look at this through Locke's eyes, we can say, well, wait a minute, which kind of essence? Are we talking about the real essence or the nominal essence? And so we can quickly say, yeah, there's a part of that diagram now I don't understand. There's an ambiguity here because we've got two very different notions of essence. And so what is it that the word water or the word triangle or the word gold or wax is really tied to? Is it this sort of common sense characterization in terms of secondary qualities, what he calls the nominal essence, or is it this underlying real essence? Is it, well, now notice with triangle it doesn't come apart because our common sense idea and the idea in geometry are just the same. But with something like an elm, being an elm, that essence, it suddenly becomes an issue. Are we talking about the biological one or the nominal one? And so here it matters. And in the end, we can either say it means just common American deciduous tree, or we can say, no, it actually means, it actually connotes, or stands in some important relation to the actual underlying real essence, Ulmus americana. So there are two options here. And the question is really, which do we use? Are we in the end talking about these real essences, or are we talking about the nominal essences? We'll come back to those sorts of problems later. For next time, we're going to be discussing problems of personal identity and how we understand it when we talk about people like